In Bayesian statistics, a credible interval is an interval in the domain of a posterior probability distribution or predictive distribution used for interval estimation. The generalization to multivariate problems is the credible region. Credible intervals are analogous to confidence intervals in frequentist statistics. Although they differ on a philosophical basis, Bayesian intervals treat their bounds as fixed and the estimated parameter as a random variable, whereas frequentist confidence intervals treat their bounds as random variables and the parameter as a fixed value. For example, in an experiment that determines the uncertainty distribution of parameter, if the probability that lies between 35 and 45 is 0.95, then is a 95% credible interval. Choosing a credible interval. Credible intervals are not unique on a posterior distribution. Methods for defining a suitable credible interval include choosing the narrowest interval, which for a unimodal distribution will involve choosing those values of highest probability density including the mode. This is sometimes called the highest posterior density interval. Choosing the interval where the probability of being below the interval is as likely as being above it. This interval will include the median. This is sometimes called the equal-tailed interval. Assuming that the mean exists, choosing the interval for which the mean is the central point. It is possible to frame the choice of a credible interval within decision theory and, in that context, an optimal interval will always be a highest probability density set. Contrasts with confidence interval. A frequentist 95% confidence interval means that with a large number of repeated samples, 95% of such calculated confidence intervals would include the true value of the parameter. The probability that the parameter is inside the given interval is either 0 or 1. In frequentist terms, the parameter is fixed and the confidence interval is random. Antleman summarizes a 95% confidence interval as one interval generated by a procedure that will give correct intervals 95% of the time. In general, Bayesian credible intervals do not coincide with frequentist confidence intervals for two reasons. Credible intervals incorporate problem-specific contextual information from the prior distribution, whereas confidence intervals are based only on the data. Credible intervals and confidence intervals treat nuisance parameters in radically different ways. For the case of a single parameter in data that can be summarized in a single sufficient statistic, it can be shown that the credible interval and the confidence interval will coincide if the unknown parameter is a location parameter, with a prior that is a uniform flat distribution, and also if the unknown parameter is a scale parameter, with a Jeffreys prior, the latter following because taking the logarithm of such a scale parameter turns it into a location parameter with a uniform distribution. But these are distinctly special cases. In general, no such equivalence can be made.